Hello, AP Stat students. Today we are going to do a two-sided test and then look at the connection between confidence intervals and significance tests. We perform a two-sided test when looking for convincing evidence that the true parameter is different from the hypothesized value of the parameter. According to the Centers for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Taya wonders whether this national result holds true in her large urban high school. For her statistics class, Taya takes a simple random sample of 150 students from her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Taya conclude? Give appropriate evidence to support your answer. So in the state portion, we are going to test the hypothesis that the true proportion of students who never smoked a cigarette is 0.5 at the 0.05 significance level, where your null hypothesis is P equals 0.5, and you're not sure whether it's greater than or less than, so we're just going to write that as not equal to. Where P is the true proportion of students who have never smoked a cigarette. I don't know why this is not moving. It's really irritating. If conditions are met, we will perform a one-sample z-test for proportions. Let's look at the conditions. Random. It is a simple random sample of 150 students. For the normal condition, we are going to take our value from the null hypothesis, so 0.5 times the sample size, and that is equal to 75, which is, oops, I don't know what I did. Which is greater than or equal to 10. And then our failures, 0.5 times 150, even though it's the same number, you have to show your work. That's equal to 75, which is greater than or equal to 10. Okay, and for the independent condition, let's see, there's 150 students that are sampled. So it's reasonable to assume, since this is a large urban high school, that there are more than 1,500 students at this school. It's reasonable to assume that there are more than 1,500 students at a large urban high school. All right, now we need to perform our calculations. So we are going to find p hat. So that would be 90 out of 150 students, which is 0.60. Okay, now we want to calculate our z score. So our z is equal to the statistic, so 0.60, minus your proportion, 0.5, divided by the standard deviation of the null parameter. So 0.5 times 1 minus 0.5 over your sample size, and take the square root. So in the numerator, we have 0.10. In the denominator, once you do all the stuff there and take the square root of it, you get 0.0408. And that gives us a z-score of 2.4495. Okay, now that we have a z-score, we can find the probability. So we can find the probability that, now since this is two-sided, you could have z is greater than 2.4495 or z is less than negative 2.4495. So all you want to do is find the CDF for 1 and just multiply by 2. So before you even go to second vars, type in the number 2 on your screen, on your main screen, and that way you don't have to worry about multiplying by 2 afterwards. So 2 normal CDF, your lower bound is 2. I'm just going to use the positive z-score, 2.4495. Upper bound is some large number. Your mean is 0, and your standard deviation is 1. Enter that into your calculator, and you will get a p-value of 0.0143. And you want to compare it with alpha, and we know that it's less than 0.05. So since the p-value is less than our significance level, we will reject the null hypothesis. There is convincing evidence to conclude that the proportion of students who have never smoked a cigarette is not 0.5 at Tea's school. So that the proportion of students who have never smoked a cigarette is not 0.5 at her school. Right. The next little portion is about confidence intervals and significance tests. Significance tests can tell us if the smaller specific population proportion differs. I don't know why that's not moving. From the entire population proportion. Confidence intervals, on the other hand, give us an idea of what the actual proportion may be. Therefore, a confidence interval can just give us more information. Let's look at the sample example. Taya found that 90 of a simple random sample of 150 students said that they never smoked a cigarette. We checked the conditions for performing the significance test earlier. Before we construct a confidence interval for the population proportion P, we should check that both n times, this one's P hat, is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10, because that is what we use for our conditions in a confidence interval. So since the number of successes and the number of failures in the samples are 90 and 60, we can proceed with our calculations. Calculate the 95% confidence interval for the true proportion of students at the school that never smoked a cigarette. So in our state portion, estimate the true proportion of students at the high school that have never smoked a cigarette. With 95% confidence. So this is a good example of doing something we learned in our last unit and seeing the connection. In our plan portion, we are going to tell what tests we're doing. We're going to do a one sample Z interval for proportions. Conditions were checked in the significance test above, yet the only thing that we needed to check was the normal condition, which we said 90 and 60 are both greater than or equal to 10. Then we're going to calculate our Z star. So our Z star was calculated by doing an inverse norm. And since you have 95% confidence, you had an area, you had a 5% left over, which we divided by 2. So our area was 2.5%, so 0.025. Our mean is 0, and our standard deviation is 1. And that gave us a Z star of 1.96, which, you could estimate it at 2 if you didn't know how to do it, since that was one of the ones I told you probably should just memorize. And so to find our interval is our statistic, which is 0.60, plus or minus the Z star, which is 1.96, times the standard deviation, which is 0.6, so p hat times 1 minus p hat over the sample size. And that gives us 0.6 plus or minus 0.0784. So our interval ends up being, lower bound would be 0.5216. So that's 0.6 minus 0.0784. And our upper bound would be 0.6 plus 0.0784. So 0.6784. And we can therefore conclude that we are 95% confident that the interval from 0.5216 to 0.6784 captures the true proportion of high school students who have never smoked a cigarette, at Taya's school. So even though the confidence interval can be more informative, the significance test allows us to test a theory or an idea. And our last little portion is a connection between confidence intervals and two-sided significance tests. There is a link between confidence intervals and two-sided significance tests. The confidence interval gives an approximate range of values P0 that would not be rejected. By a two-sided test at the 1 minus confidence level. Significance level. However, with proportions, the link is not perfect. Because of the standard error used for the confidence interval is based on the sample proportion P hat, while the denominator statistic is based on the value P0 from the null hypothesis. But it's close enough. So if we look at the formulas here, this is the test statistic that is used for a significance test, and on the right for the confidence interval here. So look at this. So this and this, they're pretty similar. They'll give you just about the same kind of information. So on the AP exam, it is acceptable to use a confidence interval rather than the test statistic to address only a two-sided alternative hypothesis, but not a one-sided one. But if you're in doubt, then just perform whatever tests that you need to perform. So do the significance tests and not the confidence interval. And those are your notes for today. Have a great day, AP Stat students.